Welcome to RAMI. My name is Paul Bogdans, and I'm going to cover some techniques to troubleshoot the RAMI multi-band antenna system for Kenworth T2000 trucks. The following items will be covered: antennas, grounding, antenna cable and bracket assemblies, the multiplexer box, and then we'll cover some advanced troubleshooting techniques. One of the most common problems found, and also the easiest to troubleshoot, is a damaged antenna. And this is due to being out in the elements. Most times the wire breaks where it is soldered to the ferrule at the bottom of the antenna. Another common problem found, and this is for any CB antenna system, is poor grounding. And this is usually due to corrosion. The type of antennas used on these trucks require a ground plane to provide the other half of the antenna. So the trucks are being used to provide half of the antenna system. So this makes placement and grounding a major issue. So now we got to remember, ground straps are not the same as a ground plane. While a ground strap can provide a good DC path to ground and help choke off currents to help make things stable, it does not provide the reflection of the antenna that is required. It has been proven over time that the multiplexer box is the least likely cause for any performance issue. So I'm going to show you a way how to troubleshoot the multiplexer box that will save you time and effort. This and additional information, including a tutorial on the basic understanding of antennas, can be found at our website, www.rami.com. We'll start with the antennas. Use a 1/2 inch and 9/16 inch wrench to remove the antennas. And now we'll go inside and I'll show you how to troubleshoot the antennas. The most common problem found is a damaged antenna. And the place where it's usually damaged is where the wire is soldered to the ferrule portion at the bottom of the antenna. So to check continuity of this, we're going to remove the cap and then cut a couple little slots at the tip of the heat shrink. We'll carefully peel this back. We want to be careful not to pull the wire out of the slot and let the top portion unspring, because this would change the electrical length for the CB frequencies. Now we're going to, because there's a protective coating on the wire, we got to either sand or lightly scrape off that coating to expose the bare wire. Now it helps if you use some type of alligator clip to connect to this point. And we're going to check for DC continuity from the tip down to the ferrule end of the antenna. And then while we're doing this, we're going to also want to twist and flex that bottom portion to make sure we don't have an intermittent break. Now we're going to check for good ground from the antenna bracket mount to chassis ground. Before we make this check, we're going to have to disconnect the antenna bracket mount from the rest of the system. And we can do that right at the kick panel where there's a cable break. So let's go inside, we'll remove the kick panel and access that cable break. Go ahead. Move this plate. Then we're going to come in here. This plate. Once we get to the cable break, we're going to disconnect the cables. And now, because this cable assembly should have a good ground to the bracket mount, we can do all of our testing from the outer shell ground portion of this connector to good chassis ground. This is going to make this test a lot easier. So on the frame, we'll find a good chassis ground, and then the other lead, we're going to go to the outer shell of this connector and we're looking for a DC continuity reading of less than 5 ohms. If we find a reading of more than 5 ohms, we're going to want to troubleshoot for corrosion or a bad connection from this cable assembly to the bracket down to the frame. Now, if after checking both the driver and passenger sides we find that we have good grounding, then our next step is to further test this cable assembly to the bracket mount. And for that step, I'm going to grab a ladder so it's easier to get to that mount. Now we're going to check to make sure that the bracket cable assembly has good connections and no damaged cable due to being pinched or crushed somewhere along the routing. To do this, we're going to first place the test lead on the center conductor of the cable assembly and the other test lead on the standoff nut, and we want DC continuity. Then we're going to go from the outer shell ground portion of the cable assembly to the standoff nut, and we want no DC continuity. And then last, we're going to go from the outer shell ground portion to the ground portion of the bracket mount, which we can access through a little slot on the plastic piece, and we want DC continuity. Now, after checking the driver and passenger sides, if everything checks out okay, then our next step is to go inside the cab and troubleshoot the multiplexer box. Now we're going to check the multiplexer box. We left the multiplexer box for last because, as we stated earlier, it's been proven to be the least likely cause of any performance issues. So first we're going to disconnect all the radio cables. We got the CB cable. Then we're going to disconnect the AM/FM cable. And then if you have the cell phone option, we want to disconnect that as well. While we're right here, I'm going to show you we have a ground strap that runs from the ground of the radio to the multiplexer box. Now, it's critical to have this connected because it helps stabilize the system. Without this, the antenna cables seem quite hot, and we believe that that's due to a lack of metal in this truck model. So now, to test the multiplexer box, we're going to connect one lead to the center conductor of the antenna cable assembly and the other test lead to the center conductor of the AM/FM cable, and we're looking for DC continuity. The next check, we're going to leave the center conductor connected to the antenna cable, and the other lead is going to go to the outer shell ground portion of the AM/FM cable, and we want no DC continuity. And the last check, we're going to connect to the outer shell ground portion of the antenna cable, and we're going to go to the outer shell ground portion of the AM/FM cable, and we want DC continuity. If a problem is found after checking both the driver and passenger sides, the first thing we're going to want to look at is the antenna cable assembly from the multiplexer box down to the kick panel, and also the other radio cables, and we're looking for damage due to being pinched or crushed. If the cables look good, then further evaluation of the multiplexer box would be required. Now we're going to go back outside and go over some advanced troubleshooting techniques. The first technique I'm going to show you may help eliminate any noise or feedback issues you're having over your radios. We have seen that when a non-metal doorstep is used, an unshielded speaker wire is used to go to the rear speakers in the bunk, that the wires act like an antenna at CB frequencies. What happens is the signal is taken back to the radio, re-amplified, and sent back over your speakers. So a simple field fix we came up with is you can use aluminum foil just at the doorstep. Put all your wires and cables in there and just shield them just like that. And we have seen this eliminate most noise and feedback issues. This next technique will require an SWR meter. We're going to look for damaged cable from the kick panel up to the antenna, and this would be damage that a DC continuity test was unable to pick up. But it could definitely have affected it to where it changed the impedance of the cable, which would change the performance of your antenna system. We're going to disconnect at the cable break and connect to the SWR meter. And we're looking for a resonant dip of around 2 to 1 or better, right around 27.17 megahertz. And this could vary a little bit because we're looking at just one antenna at a time. Now if there's a problem in this setup, you're going to see a higher SWR of say 5 to 1 or possibly a lot worse. And the resonant dip could be shifted several megahertz either to the left or the right. After checking both sides, if there's a problem on one of those sides, you'll definitely be able to see which side it is. On all models prior to 2004, there is a field fix that can be obtained through your Kenworth dealers that will greatly improve your CB performance. Due to the lack of metal on this truck model, or let's say ground plane that is offered for your antenna, at RAMI we developed a field fix that will offer the ground plane required and greatly improve your CB performance.